In this video, we are going to solve some questions on motion. This is a follow-up to the first part of the video that we did, that we explained the major concept of on motion. Please, if you've not watched that video, please go back and watch it because you need that basic understanding to solve some questions. The majority of the questions that we're going to be solving here is targeted towards O-level exams. So if we are also doing advanced level exams, you can watch the video to refresh your memory. But there's going to be a third part. There's going to be another video that is dedicated to A-level exams and to the undergraduate. All right, so let's start. Now, the first question says that a body starts from rest. So I'm going to highlight important things. So start from rest means that initial velocity is equal to 0. So u is equal to 0. And moves with a constant acceleration is also constant. Right? Which of the following quantities vary or varies linearly? So understand linear. So I will underline linear. With square of time. So varies linearly with square of time. That means you are looking for, let's say the variable is y. So it's going to vary linearly with square of time. That means that is what we are trying to look for. All right. So how do we do it? We have options: velocity, displacement, momentum. So is it velocity? Is it displacement? Is it momentum? So what's going to help us is let's bring our equation of motions into play. So our equation of motions are v equals to u plus at. V squared is u squared plus 2as. S equals to ut plus half at squared. And of course, the last one, v plus u over 2 into t. Now, careful observation or carefully looking at this at squared, pardon me. So, careful looking at these equations already gave us a clue that this equation will most likely make sense because I am seeing something that varies with the square of time. So let's observe this equation and see if it's going to give us what we want. So now, remember linear equation. Linear equation, if you're a student of math, linear equation is y equal mx plus b. So that means this equation must resemble or must look like y equals mx plus b. Now, if I work on this equation, we're told that the object starts from rest. So if we're starting from rest, it means u equals to 0. So that means I can write s equals to 0 times t plus half at squared. 0 times t is t, so I'm left with s equals to half at squared. All right. Now compare this with y equals to mx plus b. Some people say c. You can use b also. So plus b. That means I can write 0 here, which means that this equation have a y-intercept of 0. And then don't forget that slope is constant. Now in the question it says that acceleration is constant. So that means half a must be constant. And then my x squared, my x is t squared. So this equation is going to work because half of a is going to be constant. We are told that in the problem the acceleration is constant. So it means that my slope is half a, and then this equation then varies linearly with time. So I can say s varies linearly as t squared because the other one are constant. And then don't forget that what s stands for is either distance or displacement. Distance and displacement are the same thing. The only difference is that displacement is a vector quantity while distance is a scalar quantity. So distance is the magnitude of displacement. So it means that the correct option and the only one that can vary with square of time is going to be only displacement, which makes B as the correct choice to pick. I hope that makes sense to you. So if you don't get it, just rewind. You can slow it and listen again. I'm sure you're going to get it. So let's go to the next question. All right. So this is another question for you. You can pause the video and then try to solve it before we solve. So a train with an initial velocity of 20 meters per second. So initial velocity is 20. So u is 20 meters per second is subjected to uniform retardation. What is the meaning of retardation? Retardation is just deceleration, and deceleration is a negative acceleration. So I'm going to write my A as negative 2 meters per second squared. The time required to bring the train to a complete halt, the time required, so we are looking for time. Complete halt means that the object is coming to rest. Complete halt is stopping finally. So it means final velocity is going to equal 0 meters per second. That is final velocity. Now, which of our equation of motion has all these parameters? U, A, T, and V. Of course, is this equation V equals to U plus AT. So let's plug in. V is 0. U is 20 plus acceleration is negative 2 multiplied by time, which is our unknown. So this is going to equal 20 minus 2t. Take negative 2t to the other side, becomes 2t equals to 20. Divide both sides by 2, t is going to equal 20 divided 2 is 10 seconds. So the time taken for it to come to a complete halt is 10 seconds, which makes choice A the correct choice. I hope that makes sense to you. It should. Now, let's go to another question. So, the next question here says that, yes, a body accelerates uniformly from rest. So, let's pick that again. Bring out your parameters. U is 0 meters per second. So, if you're accelerating from rest, it means initial velocity is 0 meters per second. Accelerate from rest. The object was at rest, then it starts to accelerate. So, initial velocity is 0. Now, calculate its velocity. So, we are looking for velocity. Velocity is unknown after traveling 9 meters. So, the distance it travels is 9 meters. So, that's how you solve question. Right? You interpret the question, you bring out your parameters. So, which of the equations of motion has all these? U is 0, V and S. So, the one that has the parameters is S equals to V plus U over 2 into T. With that work, a body accelerates uniformly from rest. Oh, all right. I left out the acceleration part. So, acceleration is 2 meters per second squared. So, we have to change this now. This will not work. All right, so the question that asks all of this is V squared equals to U squared plus 2AS. So we have U, A, V, and S. Now we are looking for V. So V squared, starting from rest, 0 squared plus 2 times acceleration is 2, then distance is 9. So V squared is going to equal 2 times 2 plus 9 is 4 times 9, 0 plus 36. So V squared is going to equal 36. Take square root of 36. Square root of 36 is 6. So it's going to equal 6 meters per second, right? So after traveling a distance of 9 meters, the velocity is 6 meters per second, which makes choice C the correct answer. All right, that is simple enough. But if you don't get it, just rewind and watch again. Now, next question. So the next question for you is this. So it says that if it takes an object 30 seconds to fall freely to the ground from a certain height, so we don't know the height, but we know that it is falling freely. So what does it mean to fall freely? To fall freely means it's falling under the influence of gravity. So what is supplying the acceleration is gravity. All right. So this is a vertical motion, vertical linear motion. Remember in the last video we said that if the motion is vertical, you're going to use vertical equation. So all your A is going to turn to G, that is acceleration due to gravity. So it starts from a certain height. We don't know the height, but it takes 30 seconds. So the time is 30 seconds. Now we are looking for the distance covered. Don't forget, since it's falling to the ground, so the distance is going to cover is that same height, that is from here down to this place. So that means we are practically looking for the height. Now, what we are going to assume, although it's not mentioned in the question, is that it's falling from rest. It takes an object 3 seconds to fall freely to the ground. So if an object is falling from rest, the initial velocity is also equal to 0. If an object is falling from rest because it wasn't moving initially, just fall. So the initial velocity is going to be equal to 0. What is the distance covered? So we are looking for s, and then since it's under gravity, we take our gravity to be equal to 10 meters per second squared. So plug in your equation of motion. So which equation of motion has all of this? So it's going to be s equals to ut plus half dt squared. So now understand that your gravity can be positive or can be negative. All right. The best practice is to say that if it is falling, because your gravity acts vertically downward. So if the object is falling in the direction of gravity, that is, it is falling down, you take your g to be positive, and then if it's going against gravity, that is, the object is going upward, you take your g to be negative because it's going to be going against gravity. So now let's plug in. S is going to equal 0 multiplied by time plus half times 10 multiplied by 3 squared. So I didn't put 3 here because 0 times 3 is still 0. So all of this is equal to 0 plus half of 10 is 5, 3 squared is 9. So S is going to equal 0 plus 5 times 10 is 45. So S is going to equal 45 meters. So the distance is covered is 45 meters, and the height is from which it falls from is 45 meters. So it's going to make choice A the correct choice. I hope that makes sense to you. So let's go to another question because we have so many to do. So here is the next question. A ball is dropped from a height. So dropped from a height of 20 meters. All right. So this is the height. Let's say it falls to the ground. So this height is 20 meters. Okay. And rebounds with a velocity which is 3/4 of the velocity with which it hits the ground. So that means this ball, of course, this ball falls to the ground, then goes up again. All right, but the velocity with which its takeoff velocity is going to land with a particular velocity. Its takeoff velocity is 3/4 of its landing velocity. What's the time interval between the first and the second bounces? So that means the object fell to the ground, bounced off, and then came back again. So what we are looking for is the time interval between the first bound and the second bound. So this, let's say this is the first bound, it went up, but it's not going to fall to this height because the takeoff velocity is lower than the velocity with which it hits the ground. So let's say it got to this height when it went up. So coming back, what's the time interval? So how do we solve this? The first thing you would like to do is find the velocity with which it hit the ground the first time it fell to the ground. So when they say an object is dropped, that means it was falling from rest. So your initial velocity is going to equal 0 meters per second. And then it's coming down, so it's along gravity. So we take our g to be positive 10 meters per second squared. So let's find this velocity. So how do we do that? It's falling from a height of 20 meters. So s is equal 20 meters. Then we can quickly find velocity. So we say v squared equals to u squared plus 2gs. So v squared is going to equal 0 squared plus 2 times 10 times 20. So v squared is going to equal 2 times 10 times 20 is going to give us 400. So square root of 400 is 20. So v is 20 meters per second. So which means that at the first time this object is bouncing, is hitting the ground with a velocity of 20 meters per second. So now let's take the takeoff velocity. All right, the first time it bounce up. So now when it's going upward, its takeoff velocity. So this is like the second part of the motion now. The first part of the motion, it was coming down. Second part of the motion, it was going up. So now let's um, take the second part of the motion. So in the second part of the motion, it was going up. So its takeoff velocity will be the initial velocity now. All right. So initial velocity when going up in the second part of the motion is 3/4 of its landing velocity. The landing velocity is 20. So 4 in 20 is 5. 3 times 5 is 15. So its takeoff velocity is 15 meters per second. So this object acquires a velocity of 15 meters per second and went upward. So when it's going upward, it's going to get to a maximum height, to a particular certain height. So let's say this is the certain height or maximum height. Understand that the maximum height, at the maximum height attained by an object, its final velocity is going to be equal to 0. So its final velocity is going to be equal to 0. The object will stop momentarily and start coming down. So in the second part of the motion, all right, when it attains its maximum height, is v is going to equal to 0 meters per second. So we can calculate the time taken for it to get to that maximum height. So after this first bounce going upward, let's find the time it takes to get to that maximum height. So we say v equals to u minus gt. We are using minus now because the object is going upward. At maximum height, v is equal to 0. So this is 0 equal to is takeoff velocity is 15 minus 10t. Take 10 to this side, we have 10t equals to 15. Then t is going to equal 1.5 seconds. So it means that at the first bounce, okay, it takes 1.5 seconds for it to go upward. Now, what time will it take for it to come downward? It's also going to take 1.5 seconds. Why? Because the acceleration is acceleration due to gravity. It's constant. So look at it. It takes 1.5 seconds to go up. It's going to take 1.5 seconds to come down and make the second bound. So that means that the distance between, or sorry, the time interval between the first bound and the second bound is going to equal to 1.5 seconds. Or let me say that time is going to equal, it takes 1.5 seconds to go up plus 1.5 seconds to come down to make the second bound. So the time is going to equal 3 seconds. So this is going to be the correct answer. So the time interval between the first band and the second band is going to equal 3 seconds. 1.5 seconds to go up after the first band, then 1.5 seconds to come down to make the second band. So 1.5 plus 1.5 is 3 seconds. I hope that makes sense to you. That is a very interesting question. If you don't get it, just go back and watch again. It's an interesting thing. Now let's see the next question. So this question says that two balls, X and Y, weighing 5 gram and 50 kg. Right? That's interesting. We have balls of different masses. So let's say this is the first one. So this one is weighing 5 gram. Then we have another big ball. Let's say its material is more denser. It's weighing 50 kg. All right. Respectively, were thrown upward vertically. So it's a linear motion at the same time with a velocity of 100 meters per second. Right. Now, how will their position be 1 second later? So these balls were thrown upward at the same time with the same initial velocity. What will be their positions 1 second later? The tendency or the best thing we could do is, since we are given initial velocity and then we are given time, we can find the distance because position is distance. All right, so let's do that. It's going upward. So S equals to UT. It's going upward, it's going to be minus half gt squared because it's against gravity. So S is going to equal, the initial velocity is 100 times time is 1 second minus half times 10 times 1 squared. So S is going to equal 100 times 1 is 100. Half of 10 is 5. 5 times 1 is 5. So S is 95 meters. So what we are expecting is that these two objects should be 95 meters after 1 second. Now let's see our options. Option A says X will be 500 meters ahead of Y. X and Y will both be 500 meters from the point of throw. C, X and Y will be 500 meters from each other. D, Y will be 500 meters ahead of Y. Now there's no options that says that they are 95 meters from the point of throw. But what the examiner is really trying is to um, is to know, if you know that despite their masses are different, they're going to be at the same position. Why? Because all their parameters is practically the same. They have the same initial velocity, they are thrown upward at the same time, they are both under the influence of gravity, so they should be at the same distance after um, being thrown at the same time. So the best option to pick is X and Y will both be 500 meter from the point of throw. B is the best option to pick. Although it is not correct to say they are 500 meter from the point of throw, but what they really want you to know is that despite their masses are different, they are going to be at the same distance. Now, you would then ask that, oh, but their masses are the same. Why are they at the same position after the point of throw? As I said before, they have the parameters to be the same. Initial velocity, if you look at your equation of motion, there's nothing that talked about mass, right? We have v equals to u plus dt, s is ut plus half dt squared, blah, 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 blah. Nothing that talk about mass in that equation because as we said that this aspect of physics is called dynamics. We are looking at motion without considering the force that causes motion. So the only difference is that for you to give 5 gram and then 50 gram the same velocity, the amount of force that you're going to apply is going to be different, okay? Because your force is mass times acceleration. The force that you apply on 5 gram is going to be different from the force that you apply on 50 gram to give it this, or to give them this initial velocity of 100 meters per second. But since you have given them that initial velocity, we are not concerned about force here. What we are concerned about is dynamics. So since you have given them the same initial velocity, all right, and you throw them at the same time, they're going to be at the same distance, all right. So that also explains the phenomenon that talked about if you drop a stone and a feather in a vacuum at the same time, they're going to hit the ground at the same time, even though their masses are different. All right. If you drop them at the same time, because the acceleration on them is actually due to gravity, so when you drop them at the same time, they will drop at the same time in a vacuum. All right, because there is no air in a vacuum. So air displacement will not work in a vacuum, so they will fall to the ground at the same time. So the best answer to pick here is B. I hope that makes sense to you. So let's go to the next question. We still have some more to do. So let's see this question. A car moving with a speed of 90 kilometers per hour. All right, we have something new now. 90 kilometers per hour. So if a car is moving, that should tell you that this is initial velocity because something else is about to happen. All right. When they say a car moving with a speed of, this will most likely be initial velocity. So initial velocity is 90 kilometers per hour. What I would do is to immediately convert it to meters per second. Why? Because most other parameters is going to be in SI unit. As you can see, the time is 10 seconds. So let's convert it to meters per second. So to convert it to meters per second, you multiply by 1000 because 1 kilometer is 1000 meter. Then divide it by 3600 seconds because 1 hour is 60 times 60, which is 3600. But what I do is to just divide all of them by 3.6. Why? Because 1000 over 3600, if I divide this by 1000 and I divide this by 1000, 1 over 1000 is 1, 3600 over 1000 3.6. So I just divide my kilometers per hour by 3.6. So 90 divide 3.6 is going to give me 2.5. So that means this is 2.5 meters per seconds. All right. So it's 2.5 meters per second. So was brought uniformly by the application of the brakes in 10 seconds. Was brought uniformly to rest. I think it should be to rest. So V final velocity is going to equal 0 because it is brought to rest. And then in how many seconds? T is 10 seconds after the brakes were applied. How far did the car travel? So we are looking for distance. So which of the equation of motion has u, v, t, and s? That is, of course, is s equal v plus u over 2 into t. So we have I messed up on this part. So it's supposed to be 25, not 2.5. So this is going to equal, now let me erase this. Sorry, this is supposed to be 25. So we have 25 plus 0 over 2 into t. T is 10. So s is going to equal 25 over 2 is 12.5. So times 10. 12.5 times 10 is 125 meters. So choice A will be the correct answer. Right. So let's go to the next question. No. In the next question, we have two particles x and y starting from rest cover the same distance. That is important. So that means distance covered by x and y is the same. So let's put that in the equation. Distance of x is equal to distance of y. So we can just simply call it s since they are the same. The starting from rest, that's also important. So initial velocity of x is equal to initial velocity of y, and they are both equal to 0 meters per second because they are starting from rest. That part is very important. Now, the acceleration of x is twice that of y. So most people have issue interpreting this kind of question. So this is what I would recommend. Now, when you have two things, you have the latter and you have the former. So this is the latter. X is twice that of y. X is the former, then y is the latter, that is the second of a thing, x is the first. So what you do is pick a value for the latter, that is the second one, because x is twice that of y. So what I would say is that if acceleration of y is equal to a, that means now acceleration of x is equal to 2a. Why? Because acceleration of x is twice that of y. So whenever you have something, you have the former, you have the latter, what you do is pick a value for the second one and then you know the value for the first one because the first one depends on the second. I hope that makes sense to you. Now, what is the ratio of the time taken by x to the time taken by y? So what we are looking for is find time of x to time of y. All right, so let's start. The equation we use is the one that has s, has u, has a and t, and of course that is s equals to ut plus half at squared. So let's plug in. Now, don't forget that we are told that their distance is the same. So that means distance of s and distance of y is the same. So that means all the parameters, all this side of the equation for x must be equal to that side of the equation for y. So it means that u of x times t of x plus half a acceleration of x time of x squared must equal to u of y time of y plus half acceleration of y and time of y squared, right? All these parameters, the right hand side of the equation for x must be equal to the right hand side of the equation for y. Since their distance are the same, it was in the equation. So now let's begin to plug. U is equal to 0, so that means 0 times time is 0. So this part is going to equal to 0. Oh, this is supposed to be x. Pardon me. So this is so we are left with half. So half times a of x is what? 2a. We said it 2a times t of x all squared, since that's what we are trying to look for, equals to have a of y is what? A, then time of y is unknown, that's what we're looking for. So we can say that half cancel half, right? So now we are left with t times t of x squared equals to a times t of y squared. Now this is the tricky part. We need to arrange t of x over t of y. This is how you do it. T of x over t of y. This is what I recommend. Understand that the relationship between 2a and t of x is inverse variation. When two quantities are on the same side of equal to, that is an inverse variation, or not a direct variation. So now we want to arrange 2a and a, which will be on top, which will be below. Since 2a and tx, they are on the same side of equal to, they are inversely proportional. So now, if t of x is on top, 2a must be below. It is an inverse variation. Same thing with a and ty. This is an inverse variation. If time of y is below, a must be on top. That's the trick I use. Now, the second trick you can use is that whenever you want to do this kind of thing, you must do it such that if you cross multiply, you go back to this equation. That is, if you cross multiply, you must go back to this equation. If you cross multiply. So if I cross multiply, I'm going to go back to this equation. If you try and cross multiply, just see. So if I cross multiply, I'm going to have t of x squared. Pardon me, this should carry square. So I'm going to have t of x squared times 2a, which is what I have above. Then t of y squared times a, which is what I have above. So whenever you are arranging this kind of equation, you must arrange such that by the time you cross multiply, you go back to your previous equation. Now these two, of course, a will cancel a. Then I'm left with t of x, t of y. Since they are squared, you can square the two of them, equals to a over, since a is cancelled, I'm left with 1 over 2. Then what you do is take square to the other side. So t of x over t of y is going to equal square root of 1 over 2. And square root of 1 over 2 is 1 over root 2. So t of x over t of y is equal to 1 over root 2, which would be choice C. So choice C is going to be the correct answer. All right, I hope that makes sense to you. So please understand it. Next question. The driver in a motor car of which the total mass is 800 kg. All right, now mass is coming into play. It looks interesting already. So total mass is 800 kg. So mass is 800 kg, which is traveling at 20 meters per second. So this is going to be u. Remember I said in the last problem that when they say it's traveling, it most likely be initial velocity because something else is going to happen. So 20 meters per second. Suddenly observe a stationary dog in its path 50 meter ahead. All right. So a dog in its path, the distance of the dog is 50 meters away. So let's say this is the car and the driver. Then the dog is somewhere here. Okay. Dog is somewhere here. So this is the dog and this is 50 meters. Now, if the car exerts a force of 2000 Newton, so force is 2000 newtons. 2000 newtons. Okay, what will most likely happen? Right now, of course, when you apply a brake in a moving car, the car doesn't stop immediately. So what they wanted us to know is if this car is going to hit the dog or not, and then the dog is stationary. All right, so we have to go by the question. The dog is not running away. The dog is stationary, staying at that position. So what will happen? All right. So what we'll do is we are to calculate. The reasonable thing to do is to calculate the distance this car is going to travel um, um, when the brakes before stopping, when the brake is applied. So because when you apply a brake, the car is to stop. So if the car is stopping, that means um, we have one more um, parameter, which is final velocity. So final velocity is going to equal 0 meters per seconds. So final velocity is 0 meters per second. But before we do that, we have to find the deceleration, because when you apply brake, it means that the car is decelerating. So we say F equals to FE, because that is what is supplying the deceleration. Deceleration and acceleration are the same thing. The only difference is that acceleration is a negative deceleration. Deceleration is a negative acceleration. So A is going to equal F over M. So that's going to equal 2000 over 800. 2000 over 800. Let's simplify. So this cancel this cancel this. 25, 4 in 20 is 5, 4 in 8 is 2, 5 over 2 is 2.5 meters per second square. So that is the deceleration now. So let's find the distance. So what we'll say is, since we are looking for distance, we have our v, we have s, we have u, we have a now. So we are going to apply v squared equals to u squared. So we do plus 2as. Don't forget that v is equal to 0. So 0 squared equals to u is 20. So 20 squared, now it's going to be minus now. 2 times 2.5 times s. Let me chop off some of this part so that I can make more space. All right. So now we have 0 squared 0. 20 squared is 400. 2 times 2.5 is 5, so we have 5s. So take 5s to the other side. 5s is going to equal 400. Then s is going to equal 400 over 5. 400 over 5 should give us 80 meters. So now let's see what has happened. What has happened is that the car is moving. The dog is over here, which is 50 meters. But after the application of the brake, the car stopped at 80 meters. So that means the car has stopped 30 meters after hitting the dog, which I believe is going to be choice B. All right, I've erased choice A. Sorry about that. So the car will stop 30 meters after hitting the dog. Right. I don't know why the driver is stopping. I mean, 30 meters after hitting the dog is a long distance. But that's the question. So I hope that makes sense to you. It's a really interesting one. Now let's go to the next question. We're almost done. I just want to give you enough practice question so that you're going to have adequate knowledge. Now, if a car starts from rest and accelerates with a uniform acceleration of 10 meters per second squared. So acceleration is 10 meters per second squared. Then this car accelerated for 10 seconds. The distance in the last 1 second. All right, this is another thing you should know. So we are looking for the distance in the last 1 second of the motion. All right, you are not looking for the distance because the car traveled for 10 seconds. You are looking for the distance in the last 1 second. So look at it. If you travel for 10 seconds, the last, let's say this is 1, this is 10. The last 1 second is the 10th seconds, because if you travel for 10 seconds, the last one is the 10th seconds. So that means we can interpret this, the distance in the 10th second of the motion is what? All right, so that is what we are looking for. And then I want you to pay attention to something. They said the distance in the last 1 second, not at the end. So if it is at the end, that means the 10 seconds is complete, but it is in The other language they use to ask this kind of question is during, right? So if they say in or during, it means that the last 10 seconds is not complete, all right? The 9 seconds is complete, but the 10 seconds is not complete. So what you do is you find distance covered in the 9 seconds, find distance covered in the 10 seconds, and then subtract. That is the way you solve this kind of question. So let's look for distance in the 10 seconds. So we say ut plus half at squared, right? Because it starts from rest. So u is equal to 0, right? I didn't tell you about that. It should come up. If you can't start from rest, so u equal to 0. So, um, all right. All right. So 10 seconds, u is 0 multiplied by um, t 10, and then we have half times acceleration is 10, then t squared 100 squared. So we're going to have in the 10 second 0 times 10 is 0 plus half of 10 is 5, then 100 squared is sorry, 10 squared. I was looking for that because it's looking as if it's too large. 10 squared is 100. So distance in the 10 seconds is going to equal 500 meters. Now distance in the 9th second is going to equal ut, so 0 times 9 plus half times 10 times 9 squared. So 0 plus half of 10 is 5, 9 squared is 81. So 5 times 81, 81 times 5 is 405. So distance in 10 seconds is going to give us 500 minus 405. So S in the 10 seconds is 95 meters. Alright, so make choice A the best answer. Now, what you're going to notice that in the 9 seconds and the 10 seconds, some parameters are the same. The only parameters that is different is t. So you can just solve this all at once by saying that S in 10 seconds is ut plus half at squared. But when you're slotting the time, you don't put 10 squared minus 9 squared. You put them individually. So u is 0 times 10 minus 9 plus half times acceleration is 10. So this is going to equal, when you are doing this, you're going to do 10 squared minus 9 squared. All right, let's chop this part off. So S in the 10 second is going to equal half of 10, 0 plus half of 10 is 5, 10 squared is 100, 9 squared is 81. So we have 5 times 100 minus 81, 19. So 5 times 19 is 95 meters. So that's the quick way of doing this. Right, next question. We are almost there. So this will be the next question. Now, a body which moves from rest with a uniform acceleration travels 18 meters during the 3rd second. So that is what I told you. So in the 3rd second, the distance is traveled is 18 meters. What will be its velocity at the end? So pay attention to this now. At the end, not during, at the end of the 8 seconds. So that means the 8 second is complete. So to do this, we need to first look for acceleration. So a body which moves from rest means initial velocity is 0 meters per second. So let's find acceleration. So we say S equals to ut plus half at squared. So since it's starting from rest, that will be 0 times In the third second is 3 minus 2 seconds plus half times, acceleration is unknown, but this should be 3 squared minus 2 squared. Alright, so you have to do this individually. When you are doing the t squared part, don't do 3 minus 2 squared, it will be 3 squared minus 2 squared. So this will be 0 plus half times acceleration times 3 squared is 9, 2 squared is 4, 9 minus 4 is 5, so s is equal to 5a over 2. So distance is 18, right? So let's plug in 18. 18 equal 5a over 2. So to look for a, we multiply both sides by 2 over 5. So 18 times 2 over 5 equals to acceleration. So acceleration is going to equal 36 over 5. So that meters per second squared. That's the acceleration. So what will be its velocity at the end of 8 seconds? Right, same parameters is starting from rest. So we are looking for velocity. That means we have to do v equals to u plus at, right? Yeah, because we are looking for velocity. So v equals to what's the initial velocity? 0 plus acceleration now is 36 over 5. Then at the end of 8 seconds, so the 8 seconds is complete. So it's going to be 8, not 8 minus minus 7. So 36 times 8 over 5. So velocity is equal to 57.6 meters per seconds. Right. So now this will be the last question, and yes, we have come a long way. So let's solve this. The distance moved by a particle in the 6 seconds. All right, so same language again, in the 6 seconds and 8 seconds. So in the 6 seconds and in the 8 seconds of the motion are 45 meters and 53 meters respectively. Determine the acceleration and initial speed. So if you are looking for acceleration and initial speed, that means this object is not starting from rest. So u is not equal to 0, right? So distance in 6 seconds is 45 meters and distance in 8 seconds is 53 meters. So we are looking for u and a. So that means the equation we use is s equals to ut plus r at squared. That is the equation that contains all of this. So let's plug in. Let's start with the 6 seconds. Don't forget, in the 6 seconds, that will be interval between 6 and 5. So that will be 6 squared minus 5 squared. Alright, so 45 for the 6 seconds now. 45 equals to u is unknown. T will be 6 minus 5, which is practically 1, plus r times acceleration is unknown, times 6 squared minus 5 squared. So 45 equal to u plus half of a is a 6 squared is 36. So half times a times 36 minus 25. 36 minus 25 is 11. So 45 equal u plus 11a over 2. So multiply all through by 2 to cancel out the fraction. So we're going to have 45 times 2 is 90. Multiply all through by 2, right? So that you can get what I'm saying. So 45 times 2 is 90. U times 2 is 2u. 11a over 2 is 11a. So let's call this equation 1. Now, for the 8 second plug in the same thing. Distance for the 8 second is 53 meters. Okay. For the 8 second. 53 equal ut, so u is unknown. T is going to equal 8 minus 7, because for the 8 seconds it's still between 8 and 7 seconds, plus half times a times 8 squared minus 7 squared. So 53 equal 8 minus 7 is 1, u plus half times a times 8 squared is 64, 7 squared is 49. So 53 equal to u plus 64 minus 49 should give us 15, I think. 15a over 2 now. So we'll do the same thing. We'll multiply all through by 2. So 53 times 2 is 106. 2 times u is 2u. 15a over 2 times 2 is 15a. So this is going to equal equation 2. So we have two simultaneous equations now. So let me bring equation 1 below. So 90 equal 2u plus 11a. So what we'll do is we'll subtract equation 1 from equation 2. 106 minus 90, that should give us, so 16 equal 2u minus 2u is 0. 15a minus 11a is 4a. So 16 equal 4a. Then I'm going to have a equals 16 over 4, which is practically 4 meters per second squared. So the acceleration is 4 meters per second squared. All right. Now let's look for initial velocity. So acceleration is equal to 4 meters per second squared. Now you can use any of these equations to look for initial velocity. So let's use equation 1. Look simpler. 90 equals to 2u plus 11 times 4. So 90 is going to equal 2u plus 44. 2u equals to 90 minus 44. 2u equals to 90 minus 44, 46. So divide both sides by 2. U is going to give us 46 over 2. Then u is going to equal 23 meters per second. So acceleration is 4 meters per second squared. Initial velocity is 23 meters per second. So I hope that makes sense to you. All right. So if it doesn't, just rewind, watch the problem again, and then you can slow it down. I'm sure you're going to get it. So we have come to the end of this video. Thank you for staying to the end. Please like the video, share, subscribe. I promise you we have a lot in stock for you. More videos are coming in the incoming period, and then we have a lot to learn. So there's going to be another video on motion for the advanced level guys. So please watch out. If you are doing O-level exams and then you want to also learn a little bit interesting stuff, just watch the next video. I promise it's going to make you better. So thanks for watching. I'll see you in the next video.